So let's look at another 4-input K-map example. So once again, right, I've got my rows labeled here, and I've already got my truth table all labeled. Don't forget that these are in gray code order, so 0, 0, 0, 1, 1, 1, 1, 0. That's important. And let's get started here. So remember, we're putting our ones and zeros in the proper cells based on these row numbers here. And so let's just kind of go about it. Something to kind of notice or realize is this is a column, this is a column, this is a column, and this is a column. And don't forget, though, that these aren't necessarily in order, right? These are kind of, these last two entries are flipped a little bit. And remember that these don't go in order, right? These go first column, second column, fourth column, third column. So it's a little off, but either way, when I see this right here, when I see that I've got 4 ones, that means this whole column is going to be a 1. I'm just kind of sharing tricks to get a little bit quicker at this. And then here I can see I've got 0, 1, 0, 0. And then it looks like this column is all 1s. And then we've got 0, 0, 1, 1. So there's our K-map, and now let's start finding some implicants. So let's think of the growing implicant, right? We start by just circling a 1 and say, hey, this could grow. This could grow here. And then we say, hey, it could grow even more, right? We could collect 4. And then we remember that we can also go over the edges here, and we could collect these 4 as well. So there's 8 circled. Can we go any bigger? I don't think so, because the next size we'd have to be able to get a 16, which would be all of them. So let's go to another uncovered one. How about this guy here? So we could circle here, but that can actually grow a little bit further. It can grow and capture that 1 as well, and that can't grow any further. And the last little implicant we got to find here is we could circle this guy, but it could grow to be here, or we could say it could grow to be here. It doesn't really matter, because we know that it could also grow to capture these last 2 1s. And now let's just check and see what we've got for distinguish 1 cells. We've got some there, there, and there. So this prime implicant has a distinguish 1 cell, so that means this is an essential prime implicant. This big honkin' one also has some distinguish 1 cells, so it's also an essential prime implicant. And this little group of 4 has distinguish 1 cells in as well. So all of these are essential prime implicants. We've got all of our 1s circled, so that means that we've got a fully minimized cover. Now let's write our function here. So we saw in our last example, the bigger the implicant, the fewer terms represent it mathematically. Right? Its mathematical representation uses fewer terms. So let's look at this big group of 8 here. What's staying the same? Well, it looks like A changes, right? A is 0 here and a 1 here. B stays the same, and it's a 0, so that means it's B naught. And then as we go down this whole column, C and D both change, right? So C is a 0 here, it's a 1 here, it's a 0 there, it's a 1 there. So that means this group of 8 is represented by just B naught. Now, let's take a look at this implicant. What's staying the same? Well, A stays as a 0, so we've got A naught, since it's a 0. B changes, so we're not going to put B in there. C stays as a 0, so it's C naught. And D stays as a 1. And this last implicant, let's see what we've got here. A stays the same as a constant 1. B changes, right? B changes from a 1 to a 0. C stays the same. And D changes. So this is represented by AC. So you notice that with a implicant that covers 2 ones, it uses 3 variables. If it covers 4 ones, it uses 2 variables. And if it covers 8, it uses 1 variable. And of course that changes as you have different amounts of inputs, but it kind of still scales. The next power of 2 always uses 1 more variable. So now that means our final representation of this function is x equals b naught ORed with AC ORed with a naught C naught D.